All right. So today we're going to start talking about the modular programming, what that means. We're going to talk about pointers, which is the hardest topic in this class for some reason. Well, I think it's where the biggest struggle is. So let's do a little refreshment here. I have some RAM here. And let's say my operating system is a 32-bit. So this is 1000. Alright, so remember, RAM is just this big box. It's just a contiguous amount of memory. It doesn't know where one begins and the next one ends. The operating system takes care of that. And we call that a word size. And if we're using a 32-bit operating system, every address is 32-bit, right? And we can allocate 2 to the 32 addresses. That's why we are limited to 4 gigabytes of memory in a 32-bit. So, if I declare a couple of variables, let's call this age and double pay rate. When you declare those variables inside the main, of course, the operating system is going to come here and it's going to say, you want an integer. Okay, this address is available. There's going to be an integer. And actually I'll write it next to it. So this is the age. So the computer allocates some memory, and in return it replaces the name of the variable with the address where you found it, right? So when you run through the program, instead of saying IH equals 30, it's going to say IH, 0x1000 equals 30. The double is going to use 2 chunks of memory. That's why it's called double. So this is pay rate. That whole chunk. So this double pay rate is actually address 1032, 1033, and so on until 1095, right? It uses 64 bits. Well, the computer only replaces the beginning address, right? And it knows that's a 64-bit, so it knows how much memory allocates. So if I say I can do a direct assignment. Remember, the equal sign is the assignment operator. So the computer doesn't use the name, it uses the address when it's running. So it's going to say address 1000, which is here, put the value 25, so whatever that value might be. So I'm going to put it in parentheses 25, and it will be, what, let's see, 16 is the fourth, right? So 9 is 8, 0, 1, and so on. Put the value 25 in there, in binary. Next one is 10.5. I'm not gonna write that in binary. So that's the easy part, right? That's what you've been using. But there's another type. So let me ask you this. If each address is 32 bits, or each block of addresses is a 32-bit, and we can allocate 2 to the 32-bit addresses because we had a 32-bit operating system. If I wanted to store an address, how many bits do I need? It's the same, 32 bits. So if I want to store an integer, I need 32 bits, right? If I need to store a double, I need 64 bits. If I want to do a 128-bit encryption key, whatever, I'm going to need 128 bits and so on. It's blocks of 32. But if I need an address, all I need is 32 bits. Because if you notice, even if I did need more than 32 bits, I only get the beginning address, right? And the beginning address can be represented in 32 bits. It's an integer. Follow me? So, I want a place to hold addresses. So sometimes, and actually, in real life, you seldom just use primitive types. You're going to use what we call pointers. A pointer is simply an address that's holding another address. So, you remember your scanf function? So your scanf function, it takes 2 parameters. First is a string. We know it's a string because it has double quotes. It's a percentage. And we have the format, what we're expecting a digit. And then we pass what? The address, right? We pass the address of where we want things to be stored. And to pass the address, we use the and sign. So, when we talk about pointers, we're talking about addresses, because they're just an address to hold an address. So for instance, if I want to declare a pointer, well, the computer wants to know where's it pointing, what type of pointer. All pointers are the same size, they're all 32 bits. They're all addresses to hold another address. But the computer wants to know what type of address is that? Where is that address pointing to? So let's say if it's pointing to an integer, it's the same thing, you know, it's an integer, but to say it's a pointer, I have to use star at the beginning, and then I'll call it pointer to H maybe. So what the computer is going to do is going to allocate only 32 bits. Every time the computer sees a pointer, or a 64-bit if it's that kind of operating system you have, it's going to use that size. So it's going to be a pointer. So it's going to say, this is a pointer to an int. So let's put the star with blue. So pointers only hold addresses, right? That's what I said. Always hold addresses. So if one assign a value, right now is pointing to, who knows, has garbage in here. It might be pointing to an address from another program. So if you try to access that, it's going to give you a memory access violation. So I'm going to give it a value. So they work the same way. Oops. I think it's like this. When I'm assigning an address. So to assign an address, I want to assign the address of H. Well, how do we get an address? We just add the and sign. So now, in here, the computer is going to have the value 1000. So we want to change the value of H. Now I'm not adding an address, I'm saying go to that address and then put the value 50. What this is going to do, the address, whatever, 1096 now, right? So the computer replaces this. But this one has a pointer to the address 1096. What does that mean? It says go to address 1096. That's a pointer. Oh, the value is 1000. Address 1000. Go to that address, so it comes here, and then it changes the value here. Follow me? Do you read the chapter? So, let's say I declare a pointer to a double. All I have to do is put the star, and then I'll just call it pointer to A. So in here, the computer is not going to allocate 64 bits, still going to allocate 32 bits because it's a pointer and all pointers are the same size. Then I can say pointer to pay will have the address of that variable. So now 32-bit is going to have the address to something that is 64-bit. Why is that? Why do you think we need pointers so much? Everything is pointers, actually, in real programs. Real life programs, I should say.
If you're dealing with really, really big numbers, you probably would want to have to use, like, have to work that variable in to the actual loops and stuff. Probably just want to use other pointers. Just because they're smaller, you can put in more pointers and having to put more giant variables.
Well, you don't have to deal with big numbers necessarily. So this is called RAM, right? That's called random access memory. So what's happening in back end, the computer has this pointer saying this is you start your program, here's a chunk of memory. And that chunk of memory, you can use it whatever you need. So the computer starts saying, okay, this is the next available address, and it keeps going. But all of a sudden, let's say I'm not using this in between. The computer doesn't go back and make that available right away. It just keeps going to the next one. There's a timer. It's called garbage collector. That goes, I don't know, every 2 minutes, minute and a half. What it does is defrags the memory. In case, you know, you have all these gaps and then it collapses the RAM and then points to the next one. What happens is, sometimes there's two things that could happen. Something called arrays, that you want a big contiguous chunk of memory, which might become not easy to do, especially if your RAM is getting full. And another thing is, how many types or how many values can you return in a method? I mean, you did your homework, you did methods for in the project, right, to get the address. Could you return 2 values? Like, how would you write a function to solve the quadratic formula? You got x1 and x2, they're 2 separate values. What type of function will you write? When you write a double, it will be x1 and x2 are doubles. But there can be different values, right? So how could you can only return one thing, right? With a pointer, you can return 2, 3, 4, whatever many things you want. Actually, you don't return anything. You can return only one thing, but you can modify more than, you can modify the parameters that are passing. So for instance, there's a function called scanf. Scanf doesn't return anything. We don't put equals in this side to something. But somehow our variable that we pass gets changed. Right? So the value gets input into this variable. We can't, the system will not let you do this. Put a number. Because that's not an address of a variable, right? That's just a number. That's a constant. So that will not let you. So let's write, if you write everything in the main, sure, it'll work, but it only works with small programs. As you get into more complex things, then you have to start breaking it down into functions, right? For instance, in your project, you use the sine and cosine, right? You didn't write the function sine or cosine. Gosh, will you be able to do it? I couldn't do it by hand. It's like the square root. The last time I did the square root by hand was in 8th grade. And it was the day they showed it to me, one homework and the exam, probably 3 times in my life. I don't know how to do it, but the computer does. So modular, that means we start making it into modules, breaking it down into smaller pieces. So it's easier to manage, easier to debug. So we have the quadratic formula, right? That says x equals minus b squared, right? No, minus b plus minus b squared, right? Something like this, right? And the form is ax squared plus bx plus c equals 0, right? So, if you were to write that in a program, I guess you could make 2 functions, one that says x1 and another says x2. That might not be very efficient. So, is there a chance that this function, is there values that will make this function not work? Well, if a is 0, you get division by 0, right? But what if A or C are large numbers and B is a small number?
You get a negative division.
You get a negative root, right? So what do we call those? Imaginary numbers. So there's 2 things you gotta test, right? You gotta test if there's a division by 0, and the second thing is if you have an imaginary number. So we can write a function just to say if you can do it or not, without giving the answer. Without giving the answer, we can write a function that returns true or false, right? So basically, if this can be found, and we can call it, I'm just going to call it quad. That's my function for quadratic. It can be done or not. And those A, B, C, what type of variables do you think they are? Integers, doubles, characters, booleans? Can you get fractions in there? We can get fractions. So it should be doubles, right? So I need 3 doubles. So I'm going to say double A, comma, it's very similar to the homework, right? It took 4 doubles. This one takes 3 doubles, right? And so I declare a function of type Boolean that takes 3 parameters. Nothing big right now, right? And I set Well, doing division by 0 is easy. All I have to do is compare if a is 0, right? But the square root part might not be that easy. I had to do some calculation, right? So, I'm going to declare a local variable. You have your section for local variables. And I call it double square part. So that's my, without doing the square root, just doing the inside of the square. I can initialize it here at the same time. So that will be double B times double B minus 4 times double A times double C, right? Let's see. And I'm gonna do some parentheses just to be safe. Do you agree that's a square part? Easy, right? I'm gonna have a variable that I call a return. And this variable, I'm going to initialize it to now you can do it. I'm going to initialize it to true. So, how do I test if this should be false? Well, I need to compare if A is equal to 0 or the square part is less than 0. Yes?
Are these, I see, I don't know if it's local declarations for a new function?
It is a new function, and those are declared locally inside the function. So those are local variables in this function.
Okay.
So you should have a section here, right? Local variables. Then you go your calculations, right? I need an if statement. You know how to do if statements now. So if statement says if the double A equals 0, that's a condition, right, to fail. What's the other condition? Do I use an and or an or?
Or.
I use an or, right? And the or is logical or, that means there are two ors, right? And then double square part is less than 0. If that's the case, then this should be changed to false, right? Because that will make my function fail. And at the end of the function, because this is a Boolean, we must return a Boolean expression. And I'm going to write at the bottom. Let's put it here. So, as of right now, all this function does is to see if I can calculate the square, the quadratic formula.
Where's your opening curly bracket? Is that before this? Or? Oh, I didn't see it. Thank you.
You know, this function right here.
After, because I understood if double A is equal to 0, or, and I still understand that I think the double
This square part?
is less than 0. Did I get that one right?
Yeah. So we want to know this portion. We're going to make sure this is 0 or greater. Otherwise, we get imaginary numbers. So, you know, I get in trouble at work. They said, "Hey, did you run this report?" No. That's all they ask. That's all I answer. If they ask me when it's going to be done, then I'll say I don't know. Whenever when I'm finished, right? But that's what this function is doing. You say, can you calculate x1 and x2? All it says is yes or no, or true or false. It doesn't actually do it, right? But we want to do it at the same time. And the thing is, we want to return those x1 and x2s. But we can't, because a function only returns one type. I'm going to return 3 things. If you can do it or not, and if you can do it, what are those values for x1 and x2? And that's when the pointers come handy. You can make the function, just because the quadratic formula uses 3 values, doesn't mean your function has to use only 3 parameters. You can do as many as you want. So I'm going to add 2 more. And this time, I'm going to use pointers. Double x1 and x2. They're doubled, and I know they're pointers because I added the stars. So, if this condition fails, then I can write an else statement, right? In my else statement, then I can assign the values to these variables. But because they're pointers, and I'm not going to assign them an address, I'm going to assign them a value, I must use it like this. And then it doesn't matter which one you pick. That's you. be plus or minus. First one we'll do the plus. And gee, how do we do the square root? Well, somebody did it for us. We don't have to reinvent the wheel. And where do you think we can find the square root? In the math.h, right? So there's a bunch of functions there. And this goal is QRT. Or you can also use the power function that you learned and you...
Fractionalized for fractionalized forms.
Yeah, you just put the second as 0.5. It's the same as the square root, right? So you can use the square root function of the square part. And this whole thing divided by 2 times double A. If you don't put the parentheses, you can try it and then you're gonna get weird answers. And then double x2 is the same with a negative. So now we have a function that returns only one type, a Boolean, returns true or false if it was able to execute or find your x1 and x2. And if it can, then modifies the parameters that you pass, same way as the scanf function does it. Does it make sense? So, the only thing I added this time is that star. What that star is just, for now, if you consider as part of the name of the variable, it's actually as part of the type. It's, I use it like that with the star, and I can assign some values to it. So remember, every parameter is treated as a local variable. So it doesn't modify the source or the calling object or method or whatever. But this, we'll see in a minute when we come back, what actually happens in memory. Any questions so far? Yes?
Does the star mean that it's gonna be blue? Like, because it's blue in the under the quad description function.
If you can use Eclipse, it will be purple.
But
I mean, if you use Notepad, no, I just made it blue just to show you. It doesn't show blue, it shows black in Visual Studio. I just wanted to emphasize it's there. All right, let's take 10 minutes then.
This is